So here we have our lovely yet slightly soggy 2022 Kia Sorento plug-in hybrid. We are going to perform the high voltage disable and enable procedure. You will see that I'm going to follow the service manual on this because of course we want to stay safe and ensure that we're doing it properly. Plus I may add in a few additional steps that I find other manufacturers use that is going to be quite helpful and add an extra layer of safety. The first of three major steps in order to complete this high voltage disable procedure is to disconnect the 12-volt battery that's located in the trunk. So of course we're going to open up the trunk. We've got our key fob in our hand, and what we want to do is not put it back in the vehicle, but what we are going to want to put it in a toolbox or someplace far away from the vehicle, maybe a lockbox of some sort. The reason for this is not necessarily because it's a part of the high voltage disable procedure, but it's a matter of getting into a good habit. So good habits when working on hybrid and electric vehicles is typically going to be anytime you are working on the vehicle, take the key fob, put it away so that you lessen your chances of running the risk of the vehicle thinking that you're in the car and turning on the high voltage system or activating the brakes or something of that nature. In the trunk, you'll find a loop you can just pull up to access the plastic 12-volt battery cover. We'll just go ahead and pop that off. And now we'll use a 10mm socket to disconnect the negative battery terminal. Now, the reason the 12-volt battery is so important, and you'll find disconnecting the 12-volt battery is the first step on just about any hybrid or plug-in hybrid or EV high voltage disabling procedure, is that the 12-volt system controls the high voltage system. So the 12-volt system is responsible for closing the contactors that connects the high voltage battery to the high voltage components. So you can imagine that if this, let's say, terminal were to accidentally walk its way back up and be reconnected while you're working on the vehicle, that could present some problems. So what we want to do is we can just take this nice little plastic negative battery post cover that you get off of new batteries, and you can just pop that right on there. So that way, if you do end up with the negative terminal touching the post, you have the cover in between, and so no electrical connection will be made and no contactors will close, and you will not have an issue where high voltage is connected to the high voltage components that you may be working on. The second major step here is to disconnect the high voltage interlock loop, and this is going to be located in the right front of the engine compartment as you're looking at it. And it's really easy to spot because it's got this first responder cut here tag. And what this interlock loop does is the processor looks to make sure that the loop is completed, meaning that no high voltage connectors have been disconnected, indicating the possibility that someone who maybe doesn't know what they're doing is trying to touch high voltage components. And if the processor sends out voltage and it doesn't come back, then it knows that you are in the high voltage component section and it will not close the contactor. So really, all of these steps are all about not closing the contactors. So you'll notice that this does not have orange cabling or wires like this side does. We will not touch this side without any high voltage gloves. But this is 12 volts. It's an interlock loop, small wires, and so we don't need gloves yet. And it's just a simple connector, and you take the whole loop out, okay? So just like with our keys earlier, what we want to do with this loop is we want to put it aside somewhere in our toolbox, maybe with the set of keys, so that nobody can come by and just reconnect it while you're working on the vehicle, especially if it's something that you're working on overnight. At this time, the high voltage should be disconnected and disabled, but there's no real way to know for sure unless we actually test it. So this is the point where we're going to actually touch some orange wires, in which case I'm going to wear my gloves. And we are going to want to test right at the cable that's coming from the battery to our inverter assembly here. Okay, so now we have officially accessed the high voltage system. And before we test this, we need to not check the vehicle, not check the cable coming from the high voltage battery, but we need to check the meter. The reason being is that if the multimeter is not working properly and it's only reading 0 volts, you go to check to see if there's any high voltage here, and you believe that it doesn't have any voltage, when in fact it might actually have some voltage, which could be extremely dangerous or even deadly. So what we're going to do is we're going to do basically what's called the live dead live test. So we'll go ahead and turn our multimeter on. Okay, hopefully you can see the screen. And our multimeter is rated at Cat 3, so it can measure safely up to 1,000 volts. And our meter leads are also rated at Cat 3. So if your meter is rated Cat 3, but your leads aren't, you do not have a Cat 3 setup. All right, so I brought in this jump box here. So what I'm going to do is I'm just going to take my terminal test leads here, and I'm going to check the voltage of the jump box. Okay, 12.63 volts, perfect. So I know my meter is working correctly because that's about the voltage that a jump box should have. Okay, so the next thing I'm going to check is I'm going to check this inverter right here. Okay, so inside of this inverter are some capacitors which are meant to store voltage, and these are high voltage capacitors, so they are meant to store high voltage. Now, the reason why we want to wait 3 minutes between the time that we disconnected the high voltage interlock and the time that we disconnect our high voltage circuit is because we need time for those capacitors to drain. Now, Kia says, yes, wait over 3 minutes before you start taking things apart. In reality, it takes only seconds to drain these capacitors, but giving a good 3 minutes, just make sure that, hey, you know, if there is a problem, if we do have high voltage present there, it's not because we didn't wait long enough. It's because there's a legitimate issue that needs to be solved. Okay, so now that we know our meter is good, let's go ahead and test our inverter. Okay, so we're gonna go from one terminal here, hopefully you can see that, to the other terminal. Sorry, a little difficult with the gloves. Nobody likes wearing these, but you gotta do it. Okay, so we have a solid 0 volts. So you'll notice I'm making good contact because it has a solid 0, and when I lift up on it, it sort of changes, okay? But we have 0 volts, all right? So that's perfect. That's just what we want to see. If the reading was high, that could mean a number of things, but essentially that means whatever work you do on this vehicle, you need to leave your gloves on the entire time. Okay, so we know that the capacitors inside the inverter have drained. Now, to make sure that our meter was correctly reading 0 volts, we're going to go back to the jump box. Okay, and all right, great, 12.63 volts, perfect. That's what we want to see. So we know that something bad didn't happen to the meter while we were measuring it, and that it legitimately has only 0 volts here. Okay, now we want to check the cable coming from the high voltage battery. Here we go, here's the cable. I'm going to do my best to make good contact inside there with these terminal test leads, and I picked these for the purpose of being able to make good contact. Okay, and we know we've got our solid 0, nice and steady. Okay, perfect. So that is 0 volts legitimately. Oh, okay, we lost contact for a second there, but there you go, 0 volts. So we should be safe. Okay, now again, I'm going to go back to my jump box and just make sure Uh-oh, I am reading 0 volts. Oh, there we go. Okay, I just wasn't making good contact. 12.63 volts. If I was really nervous, which is probably okay to be a little bit nervous around these high voltage systems. Measure again. Okay, so I feel pretty confident at this point that my meter is accurately reading 0 volts on both the high voltage battery side and the component side. Okay, there are other components that have capacitors in them, such as AC compressors and other things, right? So every time you take a cable off, you want to just do this dead live check with your gloves on to make sure everything's okay. All right, now here's the scary part. Can I touch this circuit with no glove, right? If you trust your meter readings, which we've done the dead live test, we should be able to trust these readings. I can go ahead and touch all over here, at least this connector here, maybe not the AC compressor, okay, because that might have its own capacitor that's not draining, right, whatever the case may be. But I know that at this connector, I'm good to go. So I'm gonna go ahead and touch, and hey, I'm not dead yet. I'm sending this video, so obviously I'm not dead yet. And here we go, touch again. So there you have it. That is how we do it. And in order to enable the system, to put it back together again, we essentially just need to go in reverse, okay? So if we want to make the vehicle drivable again, after we've done our repair, go ahead and connect this back up. I need to go grab a torque wrench because this is torqued to about 7 feet-pounds, about 80 inch-pounds, okay, kind of how that comes out. And so I'm gonna go ahead and grab a torque wrench and torque that, and then I'm gonna install my interlock loop and then connect the battery. And that's pretty much it. Just remember at the end, you probably will have to clear some codes to just return it to the customer without any warning lights on, and you are good to go. Thank you for watching.